Hello everyone again and welcome to the DMSI YouTube channel, and it's truly a pleasure to actually have you all in this particular space. And in this particular video we're going to be exploring reactions that are involved in heterocyclic compounds. And this saturated heterocyclic compound, first take note that for saturated we are not looking at straight compounds or any compound that is aromatic in nature, because they are actually flat, which means that they are not, in this case, focusing on the specific bent nature. However, we'll be looking at compounds that are bent, which means that they either have an sp2 hybridization when you're looking at it in terms of the transition state, but also looking at compounds that are sp3 hybridized, which are in this case having any form of bent nature around the specific ring. And these particular cyclic compounds which are bent are going to be focusing mainly on nitrogen compounds, and in this case here we're going to be looking at specific nitrogen compounds that are specifically heterocyclic in that particular form. And these compounds will be involved in various reactions that are in focus, and these reactions will actually focus on compounds that involves nitrogen, which in this case will have a halide which is represented as X, and the nitrogen will also have lone pair that will be critical in a specific reaction step, and this is going to have two bonds that are bonded to the nitrogen, and the bonds are sp3 hybridized, and all around this particular bond, which is continuous, that goes from end to end, shows the cyclic nature of this overall compound. Take note here that this particular compound that we are looking at are called what? Amines, and these amines are specifically known to be called nucleophilic in this case, because they are known to have this interesting behavior of using its lone pair to form bonds that then acts as a less of a base and more of a particular good donating group, which donates electrons to a system. And so this particular compound, which are amines, we're going to be looking at two things in here. One is we're going to look at simple saturated nitrogen heterocyclic compounds first, and based on identifying all these compounds that you might find in big compounds in nature that are used not only in medicine but also in pharmacy or in nature, but also we're going to look at examples on how these particular compounds that are saturated nitrogen heterocyclic are used as reactants in making specific products that we are going to be focusing on, and some that you might not notice. So first off, we're going to be looking at the simple saturated nitrogen heterocyclic compound, and one here is looking at a 6-membered ring that has nitrogen present in there, and this is called piperidine. And piperidine has, take note, 6-membered rings. One of it is a nitrogen base, and this is different from this one right here, which 5-membered rings, of which one of the atom is nitrogen within the ring, and this compound here is called pyridine. And the next one here we're going to be looking at is really different from the pyridine. Pyridine has 5-membered rings, but in this case it's a 6-membered ring, which is similar to the piperidine. However, one of the carbon is removed and in place is nitrogen. So in this case we have two nitrogens in or within this particular compound, and this is now known to be called piperazine. And piperazine is one of the things or compounds that we're going to be exploring in this particular form of video, where we're going to be looking at how these atoms or compounds are going to be involved in various reactions. So we're going to look at a variation of piperazine, and finally here is we're going to be looking at this particular compound where instead of having nitrogen here we now have oxygen. and this makes a huge difference. And this makes a huge difference not only in the behavior of this compound but also the nucleophility of this particular compound. And so this compound here is called morphidine, and this particular compound morphidine is going to be our first particular compound that we're going to use as a reactant. And this particular compound will be reacting with a specific type of compound that we're going to use to create a new compound. And the next one here is a version of piperazine, and this is going to be our second case where we're going to use a reactant alongside this to create a new compound that is used on an industrial scale, specifically in the pharmaceutical sense. And finally here is pyrrolidine, which is our third particular case, which is going to be acting as a reactant. So take note, we're going to have 3 cases, 3 examples that shows how this guy's acting as a reactant is going to be used to make products. And take note that all 3 compounds here are going to be acting nucleophilically, which means they are going to be mainly nucleophiles and less of a base. So let's move on to case number 1, which is making trimetozine.